The digital transition. The Digital Transition, a podcast series created to assist those tasked with implementing digital strategies, where we will share our knowledge and experiences to support you in your transition. Welcome to The Digital Transition. I'm your host, Nathan Hildebrandt, and today I'm talking with Kelly Cohn from ClearEdge 3D about laser scanning and how technology is changing the way in which we capture existing assets. But before I talk to Kelly, I need to talk to you about our exclusive podcast sponsor, NBS. NBS, through their key product, NBS Chorus, is revolutionizing construction specification through cloud-based collaboration. NBS Chorus integrates seamlessly with your BIM in ArchiCAD and Revit, and also now in Vectorworks. Now, this increases productivity and reduces risk of conflicting information deliverables. To learn more about NBS, head to their website www.thenbs.com.au. Thanks for taking the time to talk to us today, Kelly.
Good to be here, Nathan.
Now, firstly, Kelly, for those that are not aware of who you are, and you are a big character when we attend these built conferences, you're well known in those circles around the globe. But for those that are listening today, can you tell us a little bit about yourself?
Yeah, sure. I went to college to be an architect and then rapidly found out that was not particularly lucrative.
Maybe you're the smart one here.
And so I leaned hard into technology. I was already kind of inclined that way. But I went to work for a big design build firm with my architecture degree. And probably within a year of going there, leaned into implementing Revit. Took that over nationwide for the firm. It was about $1 billion design builder. So that felt pretty lucky to do that, a year out of school. And it's the opportunity when you're on the front end of adopting a new technology. And basically grew that from just Revit to Revit, Navisworks, and then we added in Avaya, and then we realized that was really hard to use, and then we switched to Assemble, and I could throw out a whole handful of additional tools we implemented over the next couple of years. And eventually we bought our own laser scanner. We started Scan to BIM group. I was running the design technology team basically at Beck for almost 10 years. And then decided, hey, I don't really like random weekend job site engagements and working 60 hours a week, cleaning up other people's messes, particularly when I had 2 kiddos. And so got the opportunity to come to work for ClearEdge, which was actually a vendor of mine in my prior role. And I've been here for 5 years building technology into the buildings. So it's been a blast.
Now, today we're here to talk about technology. Now, can you give us this, you and I know a lot about ClearEdge, and a lot of people that are attending built conferences understand what ClearEdge 3D is all about. But for the listeners that haven't been to one of those events or haven't engaged with you before, can you give the listeners a bit of an insight into what ClearEdge 3D is about and the services that you provide?
Absolutely. And in a nutshell, we try to use computer vision, which is kind of a branch of AI, depends if you talk to Adam Sheether or not, and whether it is or isn't. But it's a branch of AI that basically we try and teach computers to look at things in a way similar to how people look at things to interpret data from it. Now, we focus on reality capture data, and all of our solutions right now, that means terrestrial laser scans or mobile laser scans. And basically, we do it to try and automate tedious processes. So, we've got 3 different products. We've got one that will automatically extract pipes and duct and structure and other elements in a building from point cloud data collected by laser scanners. we've got a tool that will compare automatically point clouds to models. So if you're trying to do construction verification, or you're trying to make sure your outsourcing partner did a good job doing scan to BIM, you can apply that tool. And then we've got a solution that's really very, very, well, pardon the pun, laser focused on the concrete scope of work, where we will take laser scan data and do things like floor flatness analysis, beam camber, beam deflection, et cetera, et cetera. So all kind of focused around that concrete scope of work. And those, that's Edgewise. That's our scan to BIM solution. Verity is our scan to model comparison tool, and Rhythm is our concrete flatness and beam deflection tool. So my marketing people would track me down and kill me if I didn't say the product names. So.
No, it's important also for the listeners that have an interest in seeing what options there are out there to automate the processes that they're currently using. Now, what we want to do is start with the beginning. Okay, so let's start our conversation the way in which surveyors and designers normally will capture details of existing built assets. Now, let's focus on that being either at the start of a new project or at the completion, so to confirm as constructed information. Now, let's go through these steps so that people can kind of understand where we're heading from where we've been into the type of solutions that you guys offer. How did surveyors capture this information in the past, or even designers?
Yeah, I mean, the hard way. I think all of us that have been on the architecture, the engineering side, have probably been the intern that had to go out on job site with a tape measure or a laser disto on an existing building and go take a bunch of measurements. I think we've all also been the intern that then got scolded later because we missed some critical measurement we didn't think about. Or we just got everything wrong because we assumed everything was at a 90-degree angle, and therefore the building was square, and therefore all of our dimensions might actually add up. We've all been disabused of that by reality. And I think, all of us have handled that with a wonderful text note that says verify in field.
Cover your ass note.
Any contractor's dream text note, verify in field. Oh, okay, great. Yeah, thanks for that. But, if you actually hired a professional to do that work rather than an intern, they would be doing that with a little bit more robust set of tools like a total station. They could go out there and shoot a bunch of measurements and use that to help validate that the broader dimensions, right? Get the overall length, get the overall width, get the overall, squareness of the building, things like that, plumbness. But, ultimately it was kind of a process that was just painstaking, bit by bit, put it all together and hope it's good enough that the contractor can build it without too many RFIs. And let them sort it out in the field for anything that wasn't right. Now, that's on the front end. On the back end, I really appreciate the question on the back end, because it just makes me want to laugh, because I think the reality on job sites is it just doesn't get as built. You ask any owner how their as-builts are when they get those turnover documents from their contractor, and they'll be like, what as-builts? It's just, we've never had the tools in this industry, or I should say, we've never had both the tools and a fee commensurate with those tools to as-built everything. It was just impossible with the amount of labor we can afford with our fees. So basically, spot checking has been the rule of the day in our industry for, a century. You check some small percentage of the work, maybe 2%, maybe 5%, and you assume and hope that the other, 95 or 98% is installed with a similar level of quality. And usually you cherry pick as a contractor, and you've done your due diligence, you've met your standard of care, and anything that's not right, well, sorry.
Yeah, no, it's definitely a hard thing, and here in Australia still we struggle to get accurate as built documents unless we have clients that have a good understanding of their assets and that they're maintaining them for the long duration. And I have had one instance where a client's asked me specifically to document in our specifications the requirements for capturing subterranean services because they own the asset. They're doing multiple stages of work and they don't want to disrupt them. So they want to invest in getting that done right. But the methodology in this total station methodology that you're talking about is where a licensed surveyor will go out and with a stick, which a lot of people do see currently on major roads around the world, surveyors on road signs, and they're there with a station sitting there with some witches hats sitting around it, and then a guy with a nice bright orange vest on walking around and capturing dimensions. So that's the old way of doing it, along with the architects and engineers doing very painstaking dimension taking and then turning it into existing drawings. Now, let's move on to more modern technologies. Now, for people that have never heard of laser scanning before or what a laser scanner actually is, can you explain what a laser scanner actually is and how it works?
Dark magic. So it's ultimately, it's not really any different than a total station. Fundamentally, total stations, laser scanners, they are optical instruments. There is a laser, some kind of laser. There's various different sources that emits light. That light takes an amount of time, very small, to travel from the emitter, hit some surface, bounce back, get picked up by the receiver inside of the instrument. And by very, very carefully measuring that amount of time, one can basically extrapolate the distance between that object and the instrument. As you can imagine, this is, not something where there's a lot of room for error given the speed of light. But total stations, most people don't realize this, they don't take a single measurement. When you take a total station and you shoot a prism or you shoot a reflectorless shot on a surface, it takes tens or hundreds of measurements. And it does that because there's always some amount of error in any measurement. There is no such thing as a perfectly accurate measurement. And the way you can reduce that error is basically through statistical analysis. If you take 100 measurements from the same exact position on the same exact surface, you average those 100 measurements, you get a much more accurate measurement than you would from just a single shot, right? Basic statistics. So with a total station, you do that fixed, measuring a fixed point on a prism or a surface. With a laser scanner, the regime is a little bit different because basically you have a spinning mirror and a spinning head, and it captures anything and everything it can see in a dome around you. So it's like a really fancy 3D picture. But, in that case, you have millions of measurements, but they're not all in the same spot. So there needs to be some kind of additional analysis and software to figure out where things are precisely. But those measurements tend to be plus or minus 1 millimeter on the high end of the hardware, plus or minus 5 to 10 millimeters on the lower end of the hardware. But you can average that out statistically the same way and get really accurate dimensions on surfaces, presuming you have PhDs with big brains on your development team that can do fancy math and figure out all that stuff, which fortunately I have those on my development team. So I'm very lucky to have them. But yeah, it's kind of fun. The top of the line scanner today takes 2 million measurements in a second as it spins around, and it takes 45 seconds to do a full dome. So you do the math. That's 90 million measurements in a single scan. And scanning is line of sight, just like total stations. It can't see through the beam or through the wall or through the floor. It just sees what you see. So you have to pick it up and move it. Right. And so you do it in one spot, pick it up, move it somewhere else, do it there. You can stitch the two together, which is a process called registration. Or you can survey each spot in and get it on survey control. Then you don't have to do the registration. You can do both, which we call hybrid registration. Big fan of that. Check out Scan to BIM University if you want to know why. And then they have mobile scanners, which are super cool, but less accurate, substantially so. And those you don't have to pick up a stationary thing and move it. You just walk around and it scans as you go, but you take a big step back in accuracy as a result of that. So
No, well, it was quite fun 2 years ago before COVID hit when we last caught up in Sydney, Australia, and yourself and one of your teammates were out here walking around the Sydney Convention Centre with a backpack, making a lot of people nervous because they're wondering what someone's carrying on their back. but at the same time, that's a technology and a process of capturing information. Now, people go. Well, actually, one quick question before we kind of move on to other technologies. What is the price point for these tools? You know, they're reasonably expensive tools.
Yeah. So, the lowest cost terrestrial, so stationary scanner is going to run you in the $20,000 range. For a true laser scanner. The highest cost instruments will be in the $300,000 range. And those will measure up to 2 kilometers and blah, blah, blah. So, there's some pretty high end stuff out there. Obviously you get what you pay for. And so you can certainly get on the lower end. You get some decreases in accuracy, kind of getting that mid range. The sweet spot right now is kind of in that $80,000 range. If you can put in $80,000 on a terrestrial scanner, you can get a really good terrestrial scanner for our kind of use cases. Mobile scanners start a little bit higher. You're generally talking about $40,000, $50,000 minimum. Those go up to $500,000. But that technology is rapidly improving and advancing. And so, those will start to come down as well and get more accurate.
But translating that to Australian dollars for our Australian listeners, that's okay. And that ranges from about 30,000 Australian dollars, obviously, to the middle range market, which is probably around the 70 to 100,000 Australian dollars, depending on the exchange rate at the time. Now, that's really expensive. But obviously, it drives great value in terms of for certain project types, we start to see business cases for these sorts of things to occur. And for a good example of that was in the lower end budget, I was looking to site measure, I think, 4 or 3 aged care facilities, which were over 10,000 square meters, which in North American terms, I think that's around the 120,000 square foot. Yeah. And I realized the time it would take to do one person to do a scan of each of those sites versus the time it would take to do a site measure. You'd need numerous people. I'd figured out it would take about 4 or 5 of those facilities to pay off the capital cost of one of those smaller devices. Now, for those that are listening out there that kind of go, but hang on a minute, I've seen some really cool advertising out there from my real estate agents. Apple are talking about this, these great tools where I can just take my iPhone and scan things, and why would I need one of these really, really expensive laser scanners when my iPhone can do this sort of stuff now? Can you explain the difference between what your iPhone is capable of versus these highly accurate, expensive tools?
Absolutely. So the 2 big advantages of the fancy, expensive tools is going to be accuracy, of course, and speed, right? At the end of the day. So yes, you can scan a room with your iPhone. It'll take you 6, 7, 8 minutes to do it thoroughly. You're going to have a lot of trouble getting that data into something like Revit or ArchiCAD, but you can certainly do it. And the accuracy is going to be plus or minus a couple of percentage points, which probably doesn't sound like much. But, if you think about a 1% accuracy, which would be fantastic result to get out of an iPhone, well, that means, right, for every meter, you're going to have, 10 mils of error, so great. So if you've got a building that's, 10 meters long, are you really okay with, 10
centimeters? You're doing the live calculations.
Yeah. I mean, come on, that's a pretty big gap. And that's honestly, you're not going to get that out of an iPhone. You'd be lucky to get probably 4 or 5 percentage points out of an iPhone in terms of the accuracy over a distance going in and out of rooms. And so now all of a sudden you're talking about, oh, great, I'm going to be a meter off over, 15 or 20 meters. Okay. Is that good enough?
No, never.
I don't think so.
No.
So, I think I think they're fantastic tools for small, kind of looking at a piece of equipment or a particular, feature or something that the client wants. Like my favorite use of that kind of scanner is like, here's a piece of furniture the client wants. Oh, go scan that thing and pull it in as a point cloud. Great. Fantastic. You don't care if you're a couple centimeters off on a couch, and it gives you real life looking content that you can drop into your model without having to go to the trouble of making a really complex piece of content in your authoring platform. So I think there's really great uses for it, but we're 5-10 years away from that kind of a tool replacing terrestrial scans. Now, eventually it might get there, but we're a ways out.
That's where your iPhone's going to have 100 cameras on the back of them, right?
Yes, and it's going to be like a giant lump, tumorous growth on the back of your phone.
But also the technology is different. It's not a laser scanner that's based on the back of your iPhone. It's actually based upon a different process called photogrammetry.
It's actually, so this is exciting news. It's actually not now.
Isn't it?
No. So actually the iPhone, they have a real live LiDAR chip. So it's actually silicon photonics. So they're actually shooting light actively out of a tiny little sensor to measure range. And they're using the cameras to basically texture map those range measurements. So it's similar to what you saw out of like, I don't know if Microsoft Connect. So this launched back with the Xbox a long time ago. So that was kind of first generation where they're using an infrared emitter with a grid array to basically project out points in a known pattern. And then they can look at that pattern and look at the distance to kind of figure that out with two cameras. Well, they've gotten better, and now they can actually get distance measurements out of those light pulses. And since they're getting distance measurements, it's actually true LiDAR on an iPhone now. It's not just photogrammetry, but it is much less accurate over distance. And so it's a really useful tool for certain small things. But if you want to go measure a 10,000 square meter building, really don't recommend doing that with your iPhone. Or even something like there's some lower cost instruments like Matterport that use an infrared and a grid array and an emitter, and they're probably like $4,000 to $5,000 to go pick up one of these 360 cameras. They're really great for real estate because you don't really care if you're 2% off, but their accuracy is about plus or minus 2%. So again, 100-meter building, 2 meters off.
Yeah. No, but it comes down to that use case, doesn't it? So then when we're looking at the price of an iPhone here in Australia, we're looking at about 1,500 Australian dollars. And the cheaper end of the laser scanners, the dedicated ones, around the 30,000. So it just once again comes down to that price point. Now,
yeah.
We've touched on it probably already, and I'm just going through it in my mind as to whether or not it's even worthwhile asking this question of you again. But what would you say are the big positives of laser scanning?
Yeah, so traditionally the primary advantages of laser scanning have been coverage. So when you go out on a job site to measure an existing building, you don't know every dimension that matters. You take as many dimensions as you can with your laser disto and your notepad, but you miss stuff. You think, I went out on site and the plan was to demolish all of the MEP. And then 6 weeks later, they're like, ooh, that's too expensive. Let's reuse some of the MEP. Well, guess what? You didn't capture any of those measurements when you were out on site. Go back to the site, take more measurements. So that kind of complete coverage that you get out of a laser scan is fantastic. So you go once, capture all the data, you come back, and then you use as much or as little of that data as you need. And so that's a big advantage. And then the other is just, actually getting true as-built conditions. So yes, the walls will be, not plumb. They'll be tilted slightly. They'll be bowed slightly. They'll be whatever they actually are in the real world. And while you may not want your building information model to represent the as-built condition at that level of accuracy, that may be not productive for the design process or for the dimensioning process. Nonetheless, having that point cloud data there so you can make informed decisions about how do you handle that discrepancy is incredibly valuable. So, I generally recommend people, you never actually want an as-built model. You want a as-intended model, which is kind of this weird version of in between as-built and as designed. It's like you know, yes, the walls bowed a little bit, but let's just model it flat. And yes, the ceiling sags a little bit. Let's just model it flat, but let's model it at the average elevation so that the contractor has a pretty good idea of what they can fit into the plenum. Those kind of things.
Now, one positive I thought you would have touched on, but you didn't. You've got a reasonably high ceiling right there, and I know you're a tall bloke, but you imagine this would be a safer methodology for capturing information on large-scale projects in terms of high ceiling. So it would save a person climbing up on ladders or scaffolding or any other thing where working at heights becomes a higher risk. So that's another one from my perspective that adds a huge level of value that doesn't have a price. There's no price attached to it whatsoever apart from, saving one's lives. But what are the negatives of laser scanning, Kelly? And I'm looking forward to your answers to this one.
Oh, gosh. I mean,
apart from the biggest issue in the room, the biggest elephant, the 1,000 terabyte issue in the room.
Cost? What?
No. It's to do with the file sizes.
Oh, come on. That's not the biggest elephant. I used to be, but now I think
we all don't have servers like you, Kelly.
Oh, trust me. I do have a NAS up there, but I built it myself. I don't know. To me, the biggest challenge or the biggest thing that inhibits adoption in the industry right now is actually the technical complexity to do it successfully. So, actually running the scanner, not that hard. You can train anybody to press the buttons on a scanner and collect scan data. Teaching somebody where to set it up to get the best coverage with the fewest number of setups, well, it's a little bit harder, but and that's certainly doable. Teaching somebody to successfully register that data to get the level of accuracy that people expect out of laser scanning, I think that's probably the hardest thing right now. Everybody, all the manufacturers, and Topcon is our parent company, and I'm going to tell you, all the manufacturers are guilty of this. They all like to pretend that registration is so easy because they're trying to sell hardware. That's how they make the money. So, it's like, oh, it's so easy, anybody could do it. And then you actually try and do it across more than 10 scans, and you go like, yeah, it's actually kind of hard. And so, I think the technical complexity is a big barrier. Yes, the file sizes are large, but that is rapidly declining as a barrier because, of course, now you can buy a 10 terabyte hard drive and put it in your computer and it costs $130. Just the price of storage has come down so much. Speed of transfer with USB 3, so much faster. Our internet bandwidth is so much faster. And I honestly don't see scan files getting much larger because we're kind of already at the peak of density. Like,
it won't get worse.
There's already a scanner that scans 2 million points per second. It scans in 45 seconds. It takes longer to take pictures with the scanner to colorize the points than it does to run the scan. Like, you don't really need a 4 million or 5 million point per second scanner. There's other things that need to get done to make this process better. So I think we're kind of capping out on the size of scan files. That's going to plateau, and we're pretty, if we're not already there, we're pretty quickly going to be past, the inflection point where that's a minor concern rather than a major concern. And tools like Revit, tools like ArchiCAD, everybody that's got point cloud viewers are handling much larger point clouds much better. And there's ways to break them up to make them more manageable. So, I think it really comes down to training people to do the registration, training people to look at the data and understand and interpret the data effectively. And that's really where that's what's kind of capping the growth right now. It's just how quickly can we adopt a technology that's still not super easy to use.
I think it's quite potent that you mention that people are the problem in terms of training people and getting them to do the right thing, which is everything in our industry in terms of trying to adopt new ways of working. It's the people that are the hardest thing. And I personally have seen an instance where we've done, examples where, where a salesperson's come in with a laser scanner and said, oh, here you go. This is how we do it. It all works with this tool and it connects directly to an iPad and then this software processes it all. Is there a method? is it technology that's holding it back? Because the whole thing is that some things obviously can be made easier through the use of technology, but then because humans are never going to be capable, if we just assume humans at the lowest common denominator of expertise and saying, well, here's this tool, we've taken all of the potential failure points out of it. Can technology? I know you're sitting there going, "Geez, you're dreaming," and I want 50,000 times more developers to do what you're talking about. But do you think that technology has a way of kind of bridging a little bit more of that gap that we're facing because humans are struggling to bridge the gap?
Yeah, I mean, if you'd asked me this question 10 years ago, I would have been like, people are the problem. Yeah, people. Give me robots. Having spent 5 years working at a software company, basically training bots in a manner of speaking behind the scenes to interpret point cloud data, robots suck too. My perspective on this, I think, has wizened a bit, or maybe become more jaded. I don't know which way to say it, but
it's just more aware.
Yeah, and that's certainly true. But at the end of the day, I think people, yes, have a hard time changing. I find that people, given the right incentives, change quite easily. Because we're very adaptable. So, my kind of experience 10 years doing VDC stuff in a big firm is that mainly I did the first 8 years of it wrong, which was that
you're doing all the hard learning.
Yeah. Well, and I was trying to focus on, here's how the technology, makes your life easier. Here's how the technology is better. Here's how the technology is cooler. It's more interesting. You get to have more fun. Like I was focused on the wrong thing. And it took me a number of years to realize at the end of the day, it's just a business decision. And so I think, when you try and force technology on people without a compelling business reason to do so, you get a lot of resistance. And there may even be a compelling business reason to do so, but if you can't articulate it, not everybody is capable of seeing it for you, right? And so the trick is to figure out how to articulate the compelling business proposition. And then it becomes really easy to implement the technology if there is one. And so, to me, it's like, yes, people resist change. But if you show a project manager how they can produce the same amount of work with 7 people instead of 10 people, and that means he gets to have the most profitable project in company history, which means he's going to get promoted to principal, he's going to flip and do it. But if you tell him,
You'd hope.
Yeah, well, I mean, you hope, right? But and yes, there's always the Luddites, but most reasonable people in that situation will do it if they believe you, and that involves proving out credibility and doing it in small steps, et cetera, et cetera. But I mean, we could spend hours talking about the trials and tribulations of technology implementation, and I just sum it up by saying I think it's a balance. The technology needs to get progressively easier to use. As it does, it becomes viable for a larger percentage of the population to use it. And so there's I can't remember the book right now. It's like the innovators. Anyway, there's a lovely curve that talks about, you've got the early adopters, you've got, the kind of middle of the road people, you've got the Luddites, the laggards, whatever you want to call them.
There's a chasm of whatever it's called.
Crossing the chasm. Thank you. You triggered the right word. So yes, crossing the chasm. So it's a great book because I think it talks pretty effectively about that balance. So there are people who will adopt technology even when it sucks just because they want to and because it's part of their identity. Then there's people who will, adopt technology because it makes sense or because they see promise. Then there's people that will do it because it makes sense. And then there's people that will never, ever do it. To hell with you. And you ignore those people because they will eventually be replaced either by retirement or by losing their jobs. You focus on the ones that will adopt it reasonably, and the goal is to get the technology to the point that a reasonable person will adopt it. And I feel like we're probably across the chasm with laser scanning, but it's very recent. And so, we're still making improvements to make it easier for more and more people to adopt. But I think we're getting really close. If we're not already across, we're really close to that point. So I'm pretty bullish on the next 5 years in terms of adoption of reality capture in the industry, because I think it's just getting easier and easier to do. It's getting cheaper to do. And man, it's really hard to justify not doing it on a renovation project right now if you actually know it and understand it. It's just, God, it's really hard to not do it.
No, I can perfectly understand that. Now, moving on to the next phase. So we've got this beautiful point cloud, and we're absorbed with all this data to the point where, as a designer, we are probably overwhelmed once we have brought these point clouds into our BIM authoring softwares. The challenge is that, in my view, and this is and I'll be interested to capture your ideas on this one as well, but my views is that I wouldn't save any time on the production of the existing conditions from either a noted sketch of all the dimensions that I'd taken from an old method versus converting a point cloud into a model. I've always kind of seen those processes as being equal time in generation. Now, that's because the process of trying to deduct the average manually of a point cloud for walls and floors and ceilings and the like can take a little bit of time. Just a little bit. And people can't see we are talking to each other via video link. So there is some little fun hand gestures pointing to each other. But
just a little bit.
The thing is that we've turned around and we've got a process where we're now using laser scanners to capture information. So we're capturing information more accurately and more efficiently, and hopefully more effectively. Moving forward to the process of actually turning that into a model in our authoring platforms. Now, that's the type of thing that I think is where the leap of automation needs to occur. And thankfully, I'm talking to the right person today. Surprise, surprise. We have had numerous conversations about your product and where it's heading into the future, but things that we can't talk about on this call today. But one of the things I do want to understand, and for the listeners to understand, is about your products that can automate the process from point cloud to a model that is essentially a base, and you're admitting that the automation isn't 100% perfect, and nothing is, because the computers are still learning like we are. But it captures certain architectural elements, it captures certain structural elements, and it captures certain mechanical and electrical elements and converts them. So do you want to just talk through briefly what that process is and what actually eventuates in our authoring platforms?
Yeah, absolutely. So, I mean, for people that have never worked with a point cloud before in their authoring application, you basically have three choices. You model it manually. So think of it as almost like tracing a CAD background, except you're just tracing a 3D background that happens to be ridiculously accurate. So there's one way to do it. That tends to be very manual. It tends to be a little tedious. You spend a lot of time like, well, is this the middle of the wall? Is that the middle of the wall? I don't know. And at the end of the day, I will say it's still better than doing it from hand measurements written down in a journal. So don't. We'll get to that in a minute. I will get on a soapbox about how often new technology gets compared to perfection rather than what it's replacing, and that's also a huge barrier to adopting technology. It's like, well, it's not perfect. Well, yeah, because an intern measuring with a tape measure in the field is perfect. No, you crazy. Anyway, so it's a good way as a starting point, and I encourage anybody to try it because it's hard to evaluate the other two options if you haven't tried it the hardest way. Kind of the next option is what I will call manual extraction. So rather than tracing, basically this is where you use the computer to computationally figure out where the thing is, right? So you basically draw a little box around a pipe, and the computer figures out how big the pipe is, and it puts a pipe there. And there's a bunch of tools that do that. So, that's, sure, our software can do that, but so can 15 other vendors' software. So that is a way to improve the accuracy substantially of that modeling process, because the computer is, I guarantee you, going to be better at figuring out where the average of 10 million points are than you are as a person. And it's going to do it with accurate slope and twist and anything else, right? So, whereas the person will just assume it's plumb when they go through that process. Now, you may or may not want that additional accuracy, in which case there may or may not be a big advantage to doing so, because you're still touching every single object yourself. The last option is automated extraction, and there really aren't many companies that do that. So we're really the only one focused on the vertical construction space. So our software will automate specific things, because everybody wants the easy button. We want to make the easy button, but turns out it's really hard.
If the easy button was easy, everyone would have easy buttons.
Exactly. So, it turns out it's really stinking hard. We have an algorithm that you can send it terabytes of point cloud data, and it will find 80 to 90% of the cylinders in that point cloud data, model them very accurately, and to do it in a very short amount of time, which is wonderful. But that's not going to help you get rectangular duct, and that's not going to help you get W sections, and that's not going to help you get. So, every one of these things is like a bespoke algorithm with man years of development behind it. And so, right now we have tools that will do pipes. We can do structural members, so wood, steel, concrete, based on catalogs. When I say, and I shouldn't say pipes, we do cylinders, which could be pipes, could be conduit, could be round duct. And then we have some tools to help out, but with less automation, on rectangular duct, and then cable tray, and then we can do some stuff with terrain. And then we have one that's focused on walls, and that one also has a very high degree of automation. So we'll get 60, 70, 80% of the walls for you. Does everything join perfectly? Is everything the right height? Do we get some false positives? Yes, because computers aren't perfect. So if you've got nearly floor to ceiling doors and you leave the doors canted open at 45-degree angles when you scan, guess what? Every door is going to look like a wall, right? But I guarantee you, you can delete 30 doors that think they're walls a heck of a lot quicker than you can model 400 walls.
I think so.
And so part of it is also just getting used to a slightly different process. When you go down this automation route, you have to realize that you're no longer the modeler, that you're actually the QA/QC person. Like, your job is to QA/QC what the computer does and to focus on that. So get rid of the handrails that aren't actually pipes, to get rid of the, doors that aren't actually walls, to, join walls together that maybe didn't quite meet because there's shadows and gaps in the scan data. So it's a very different process, but just as a rough ballpark, most of our customers, if you ask them if they were planning on spending 1,000 man hours to do scan to BIM on a project, if they use our software, we'll cut that down to 400 hours or 300 hours or 200 hours, right? Depending on the scope of work and what they're modeling. So, a 50 to 80% reduction in man hours, that can have a pretty positive impact on your profitability as a business.
But also your program. Everyone wants everything yesterday.
Yeah, well, and it helps it absolutely with schedule. There's all sorts of things, and it's not going to do everything for you. But I always like to describe our software and most automation solutions. They're there to give you a head start. They're not there to replace you. They're not there to get rid of half your team. They're there to give you a head start. And if you use them properly, they give you a massive head start. And that gives you a competitive advantage over anybody not using that kind of a tool. And hopefully helps you win more work. You get to decide whether you want to, use that extra money as more profit or lower pricing or a mixture of both. when you're going out there and chasing work. But yeah, I mean, I could talk about Verity and Rhythm too, and similar stuff. But at the end of the day, going from scan to BIM, we're here to give you a head start. And then you'll use other tools. We don't really see ourselves in competition with any of the other vendors out there. Our quote unquote competition, most of our customers use our software first, and then they use their software because their software does other things that our software doesn't do. It's still helpful for them. And so it's kind of our software, then their software, then it goes into the authoring platform. So it's a mixture, and that's perfectly fine with us.
So it's a complementary suite of tools to essentially enable you to get an outcome rather than just thinking that one tool will do everything.
Yeah, we're not at that point. There is no ArchiCAD or Revit for scanning, right? It's still something where you're putting a couple of tools together to kind of get the whole process soup to nuts.
Oh, even ArchiCAD and Revit don't work solid by themselves. They need a few extra bits and bobs to give you all of the tools that you need. But yeah. I know that we've gone well into this discussion, and I know that we could probably talk for an hour alone on this, but if someone is looking to engage someone to undertake laser scanning, what would be one of the key things or a couple of the key points that you recommend that they consider in their scope of work request?
Absolutely.
Because we talk about this. This could be a whole conversation in itself, and I think I've seen presentations that built on this itself. But in terms of like a couple of key points without kind of being over the top.
Yeah. I mean, the biggest thing that I would encourage people to do is really think about what accuracy you actually need, because a lot of people want to specify something ridiculous. And with ridiculous specifications come ridiculous costs. So the other thing I've noticed is part of the reason people think laser scanning is so expensive is because they ask for something like 3 millimeter accuracy across a, 10,000 square meter project. Well, okay, it can be done, but it costs a lot of money. If you're okay with a 10 millimeter accuracy across the whole project, a lot cheaper. So really think about what level of accuracy you need out of the scan data. And then if you're engaging more than just scanning, if you're engaging scan to BIM and you're actually deliverable, your deliverable is a model, I would encourage people to think very much like you would doing your own BIM implementation plan. You don't model everything at the same level of detail, right? You don't model every nut and bolt on everything in the project. You only model nuts and bolts on stuff that matters to model nuts and bolts on. So the same thing is very much true of laser scanning and scan to BIM. Think about it as by scope. Break down your project by scope and think, how accurately do I need walls? How accurately do I need ceiling tiles? How accurately do I need this? And because again, the higher the accuracy demand, the higher the cost. And on a lot of these things, people don't need it to be plus or minus 3 or 5 mils. They just don't. And if you don't put it down, because that's just going to blow your cost up. If you want a good resource for that, it is a US resource, but there's a group called the US Institute of Building Documentation. It's www.usibd.org. And they've got, it's like a $250 membership or something. And they've got all these documents for RFPs, RFQs. They have a level of accuracy spreadsheet. It's a lot like the level of detail spreadsheets that you're probably familiar with in BIM execution plans, but it's specific to scanning. Super low price to pay to get something that'll help you go through that process that's been tried and true, tried and tested, I guess I should say. So great resource. Yeah, there's a US in front of it, but just ignore that and focus on the IBD and take advantage of that. And then, I think that's the
short version. That's really important. That's really important though to understand though, because even when you deal with normal licensed surveyors, and this was a conversation I had with a licensed surveyor about accuracy that we nominated in our general specification of expected accuracy for certain areas and certain elements for a traditional survey from a total station. And people need to understand that tolerances of levels within grass, for example, you can't get it within 10 millimeters. If you put it within 30, 40 millimeters, you half the price in terms of how much it costs to capture that to that accuracy. So people really need to think about that benefit. And the level of accuracy specification that you talked about, Kelly, I think it's a powerful tool in terms of, and my view is that it actually should be actually used for a level of development should actually be removed at the end of design, and the level of accuracy specification should be put in place for as constructed and for existing conditions. I think because the LODs mean nothing once an element's actually in place. And the beauty of that specification is they have different classifications for accuracy. So you don't have a blanket requirement for each item to be within certain accuracy. So, for example, and this is something that's really important, is it just important to know that there's a light fitting within that space? So you could say, well, the ceiling has a light fitting. I know it's within 100 millimeters. That's okay. Whereas certain pipe work in certain walls, you might want them more accurate. But you've also got to remember about the methodology of capturing this information. So in an existing built asset, are they going to be removing wall linings to actually, or ceiling? So it's a ceiling tile system, or is it a flush set ceiling where you actually can't get into the ceiling space? So they're the key things to think about, I think, before you embark on looking to get this pricing undertaken. And we've talked about the benefits of laser scanning from an asset owner's perspective earlier in this series once we spoke to Greta from Brisbane Airport Corporation. But I think today we've talked about the technical side of it. And Kelly, thanks very much for your time, mate. Greatly appreciated.
Hey, my pleasure. Happy to chat more another time. I do have to say, I really want to meet your duck.
Oh, well, thankfully the microphone at my end is not picking it up in the recording, but it's a set of crows that are very happy at this time of year. They're just, it's baby season over here for all of the animals and birds being spring on our side of the globe.
That ruins my ducks in a row joke. Oh, well. Oh. Crows in a row. But.
No, well, it's a challenge, isn't it? But one question, mate, one final question, one that I ask every one of my guests. What does BIM mean to you?
So yeah, this is my favorite old soapbox. So I am a big believer that the modeling in BIM, building information modeling, does not stand for what you think it stands for. And I don't mean you specifically. I think you and I have actually had this conversation like 4 years ago. But to me, the value in BIM is not the B in BIM is the 3D model of the building. It's the building. That we already have building. We don't need to say building and model. I is obviously information, but anybody that's watched the weather understands when they talk about the weather model. That's what the model in BIM is supposed to stand for. It's a model from which to predict outcomes. That's the entire purpose. That's why we do BIM. We do BIM to predict outcomes, whether it's schedule, whether it's cost, whether it's quality of design, whether it's, how it looks when you sit down in this chair or walk through the lobby. BIM is a tool to predict outcomes. And if you stop thinking about it as a modeling tool, as if the model is the end result, and you start thinking about it as a modeling tool to predict the outcome, that is a complete change in perspective of how you think about applying BIM as a business. And so that's particularly when I'm talking to executives or principals or people like that, and they bring this up, like that is the thing I harp on is like, guys, you're thinking about it wrong. BIM doesn't create a 3D model. BIM creates the opportunity for you to predict the schedule, or to predict the cost, or predict this, or predict that. And if you're not using it for that, you're using it wrong. So stop thinking, it's just like I don't know if Princess Bride is as big in Australia as it is in the United States for people of our age range, but it's like, you keep using that word, but I do not think it means what you think it means. Like that's modeling in BIM. You keep saying modeling, but it doesn't mean what you think it means. It means predictive analysis. That's what it's for. So that's my BIM soapbox in a nutshell.
No, I think that's very eloquent, and I think it has a true sense to it. I focus on the information side, and I like how you change the view on how people see modeling. But thanks again for your time, Kelly. Greatly appreciated. And for more information on Kelly and ClearEdge 3D, please head over to the podcast section on the Skewed website for further reading. I look forward to sharing our next podcast with you in a fortnight's time. Until then, good luck with your digital transition. The digital transition.